Okay, as Alex said, after logging to the cluster system, the next very important task is to submit your computational jobs, right? This is the purpose of using the HPC cluster system. So I'm going to talk about how to submit your computer jobs and how to use Slurm in this session. So the first question is, what is a compute job? So a compute job is nothing more than a sequence of commands. So you just put a sequence of commands, run your program or run your application from line to line, and then you have a job script. But unlike normal bash script, you also need to provide the required resources so that the cluster system can schedule. And regarding to the required resources, you need to provide, for example, the compute time or the wall time you would like to give for your compute job. For example, 1 day or 2 days or even longer, 1 week. And then you need to specify the number of the CPU cores and also the number of the compute nodes. At Paderborn Center for parallel computing, we have one cluster system has about 1,000 compute nodes. Yeah. Do you want to use all those 1,000 nodes? That's possible, but yeah, normally you won't want to use 1,000 compute nodes, but you need to specify the number. And also the main memory, how much memory do you need for your calculation, 100 gigabyte or 1 terabyte or even more. And maybe you heard of it, the so-called accelerators. For example, GPU can be used as accelerator for your calculation, or FPGA can be used as accelerator for your calculation. If you need to specify the accelerators. How many accelerators would you like to use? And last but not least, software licenses. For some commercial software, there is a license agreement. We need to follow the license agreement so that in some cases you need to specify the license in your job script so that only you as a user of the software can use it. So after finishing the job script, as you can see, basically it's just a bash script with many options, and then you can submit this job script to the so-called workload manager. A workload manager makes a plan for when and where to execute your calculation, to execute your job, and also on which compute nodes here, as you can see here. For example, autos, there are about 1,000 compute nodes. So on which compute nodes and when to execute them. So for Noctua 2 and Auto system, we use Slurm as workload manager so that our users will have identical experience no matter which HPC system you are using. So the experience is identical so that you needn't to learn something more. So if you have knowledge of Slurm, and then that's enough to run your job on all the HPC clusters at PC2. So regarding to the high-level principle for a workload manager, here is a figure showing you 2 compute nodes, and each has 2 CPU sockets, and how a workload manager works for such a configuration. So first of all, node is used by default in the so-called shared mode, which means multiple jobs like job A and job B, may run on the same compute node at the same time. This maximizes, let's say, the utilization of computing resources, right? If we only allow one job to run on one compute node and this job only uses, let's say, one CPU core, this is a waste of resources, right? Because the other CPU cores are doing nothing. So by default, the so-called shared mode is enabled. And in some cases, you may require large amounts of memory for your calculation. I don't know, maybe 1 terabyte memory for one CPU core. Yeah, that's possible for some really memory-hungry applications. And then in this case, this will result, let's say, more CPU core allocation. Because, for example, if your calculation uses all those memories in one compute node, and even in this case, you are using only one CPU core, there's no possibility for the other jobs to run because there's simply no memory, because this one single job use all the memories, right? This makes sense. So in some cases, if more memories is used, and then this means correspondingly more CPU cores are also allocated. And in some, let's say, cases, you may need to allocate one entire node for your calculation exclusively, which means no matter how much resources you would like to use for your calculation, I don't know, maybe only one single CPU core, 1 gigabyte memory, but you can run your job on this compute node exclusively. No other's job or even no jobs from yourself can run on this compute node. This is also possible. There are some use cases for this situation. For example, if you want to benchmark your calculation, right? You want to get very accurate timing for the runtime of your application, and then this is a good use case, because in this case you can get rid of the influence of others' job, right? So this is very useful for benchmarking. This is a very high level about how to use workload manager, or how a workload manager works on the cluster system. Next, I'm going to give you about some, let's say, concrete Slurm options so that you can put them in your Slurm job script. So to create a Slurm job script, you need to provide additional informations, like, for example, the name of your compute job. But this option is optional, so that is why it is in parentheses. And if you want to specify the name of your compute job, there are also two different ways. One is to use this short, abbreviate way, let's say minus capital J, to say, okay, this is the name of my job. Or you can use, let's say, this full option, minus job minus name equals my job. Either this shorter option or this longer option works. And then you need to specify how long would you like to run for this job. This option is not optional. This option is required for the scheduler, so that the scheduler knows, okay, for this job, the scheduler will schedule 2 hours slot for this job, no more, no less, just 2 hours. That is why this is required, mandatory. And then next one is for which project would you like to use for this calculation. So you can specify minus capital A for account, or minus 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 account to specify the compute project that you are a member of. And then you specify the number of the compute nodes using minus capital N or nodes to specify the number of the nodes. Last but not least, you may also need to specify the partition for your calculation. This is also optional. You can specify by say minus p normal, which will put your job into the normal partition. And I'm sorry for my, sorry, maybe I close my, yeah, sorry. Currently on Autos, there are 4 partitions, and the normal partition is the default partition. You can run your calculation for maximum 21 days, and the purpose is for normal jobs. But if your calculation requires more memory, you may want to submit your job to the large mem partition to specify minus p large mem, and then your job can use up to 1.5 terabyte memory. This is quite a lot memory. And if your job can benefit from GPU or FPGAs, and then you can use GPU or FPGA partition for your calculation. And for those options, you can use them to submit your job in 2 different ways. One way is to specify those options on the command line, like sbatch, and then followed by those options. Here, minus t 0030, this means 30 minutes. And then to submit this bash script as your job script. And this approach is identical to put every options here as your Slurm options, and then to use sbatch to submit this script as a whole job script. And regarding to the format for the wall time, you may need to pay attention, especially here. For example, this 3 minus 00, this means 3 days, not 3 minutes. So, to schedule a job for 3 days and for 3 minutes, this is quite different, right? So you need to pay attention to the time format so that you specify the correct runtime for your job. And after you finish the submission of your job, you can take a look at the status of your job by using SQ, as you can see here. And then you will see a list of the jobs that you have submitted. And normally, you will only see your own jobs as a normal group member of your project. And only the PC or PA, PC project coordinator or project administrator can have the permission to look at the jobs submitted by group members. And if you run SQ, you will see, for example, the job ID, the partition, the name of your jobs, the user, and here the status of your job. PD means pending, your job is in the pending state. And R means running, your job is in the running state. As you can see here, the nodes for the pending job, of course, if the job is in the pending state, there's no compute nodes located. But for the running job, you will see the compute nodes located for those jobs. Yeah, normally, users are impatient, especially when submitted jobs, you want your job to run as soon as possible. And then here we have this command sPredict, slurm predict, to estimate the starting time for your job. This is only one example. After submitting a job, if you run sPredict, you will see the estimated starting time for your job. This is only an estimation. Sometimes you will see this not available if the queue is very long. There are thousands of users on the cluster system. They may have submitted, I don't know, 5,000 or even 10,000 jobs. And then the prediction may not be really accurate. So this is an estimation, not like, second level, accurate, at this second, this job must start. This is only an estimation, but this information is still very useful, to have an overview. And then if you want to have more overview about the cluster system, you can use scluster or sinfo to have the utilization of the cluster system. For example, if you run scluster, you will see autos status, current status for all the partitions, normal partition, large mem partition, and so on, the total number of the nodes, the used nodes, idle nodes, reserved nodes, and unavailable nodes, etc. And those unavailable nodes may, let's say, have maintenance or may have even hardware errors, so that we need to change some parts and so on. So that is why you see here some nodes are not available. Yeah, because this is a cluster system. There are many computers. And then if you want to get some details about a job, you can use scontrol show job and then followed by the job ID. And as you can see, this is really a detailed list of your job. But fortunately, most of those informations are not really significant for our users. The first most relevant information is this priority. As you can see, I highlighted those information in red. Priority is very important. Yeah, if your job has a higher priority, your job will be scheduled earlier than the other's job. And then the job state, as you can see, there's nothing to worry about. The job is in the running state. And then on which compute node or on which compute nodes your calculation is running, this is also an important information, especially, for example, your calculation due to some reasons just stops. Yeah, there can be some hardware issues or some other problems, and then this node list is very useful for you and also for us if you tell us to do troubleshooting. There are hundreds of compute nodes. We are not able to go through all those hundreds of compute nodes, so it's better to have this information for troubleshooting. And last but not least, the working directory and the error message for your calculation and also the output for your calculation are listed here, so that you really have an overview about what is going on, right, for your calculation. And we just talk about the job priority. I think this is a very interesting topic. And for the job priority, there are many factors contributing to the calculation of a job priority. For example, how about the usage of your project in the last 30 days or in the last 90 days, and also in which partition, and also how long has your job waiting in the queue. I mean, a job submitted or waiting for 3 minutes may have very large different priorities than a job waiting for 3 days, right? This makes sense. So there is a very complicated formula to calculate that, but for the usage of the system in the last 30 days or 90 days for your project, you can use PC2 status to find out the status. How about the usage for your project? And for the details, if you really want to know all the details about the job priority, I would like to recommend this documentation from PC2 so that you know the priority, how the priority is calculated. Yeah. And next is S-cancel. So if you realize, okay, there may be some typo, some small error in your job script, and then you can use S-cancel command to cancel, for example, the job ID, or to cancel a job with some names, or to cancel a job of a user. So basically, if you are a normal group member, apparently you can only cancel your job. But for project coordinator, he or she may have privilege to cancel jobs from some other users. Or you can cancel interactive jobs. And the next one is to modify a pending job. For example, if you have submitted 10 jobs and some of them failed because of not sufficiently large memory, and then you realize, okay, I need to submit my job to the so-called large mem partition instead of the normal partition. And then instead of cancel all your own jobs, this is ridiculous to cancel 20 jobs or even more. You can just simply update your jobs waiting in the queue, right? It will be perfect. You can simply update your job with job ID or your account, and then to update those calculations to the large mem partition. And in some cases, for example, the cluster is very full, and then you want to run some test calculation for, I don't know, 2 hours or even 1 hour. There's no slot for 1 hour or 2 hours, but there may be a slot for 30 minutes. And what you need is to just run a quick test. And then you can update your job information, the time limit, to 30 minutes. And then the scheduler may schedule this 30-minute job immediately, because 30 minutes, this costs, let's say, almost nothing. So those are the very useful tricks. So if you want to, yes, please.
How can we know we have a 30 minutes available in cluster?
Yeah, this is difficult for normal users. Yeah, this is. I think this is difficult. You need to have, let's say, more privilege to have Slurm. But if you only want to do some quick test, yeah, it's better to not specify 3 days or 3 hours, just 30 minutes. This is, let's say, just some small tricks to help you to submit jobs, to schedule your jobs more quickly. And then you may have a problem that you want to submit even more jobs. Let's say, I don't know, hundreds or even thousands of similar jobs. For example, you want to simulate a system, I don't know, with a parameter of 1, and then you want to simulate a similar system, but with parameter of 2 or parameter of 3, and so on. You want to just run all those, I don't know, 1,000 similar simulations. And then it would be, let's say, tedious to type your keyboard S batch 1,000 times or write some other script to control those 1,000 jobs. And then the solution from Slurm is to use the so-called job arrays. So you can submit your job script and then specify the starting ID of this job from whatever integer, can be 0, can be 1, can be 2, just specify the starting ID and then the end for your job script. And then Slurm will create an array of jobs like what you see here, a job ID, but with underscore different numbers, different IDs in this array. And then, as you can see here, I'm running 500, let's say 512 jobs in the normal partition, and some of them are running, and most of them just in the queue, and sooner or later, those jobs will be scheduled, and so on. And to make use of this array of jobs, you can utilize the so-called Slurm array task ID. For the first job in this array, it has ID 1. For the next one, it has ID 2, and so on. And then by using those environmental variables, you can control your job script, to make your submission or follow-up data analysis automatic. This is very, very convenient, because otherwise, to submit 1,000 jobs, this is insane, let's say. And yes, in this part, I talked a lot about Slurm options, and I think this is also a lot information for you. To make this part more practical, we created this Slurm cheat sheet for you, so that maybe you can print out this slide. And here, this table shows you the number of the CPU cores, for Noctua 2, and number for one compute node. Yeah, by the way, one compute node. And autos, one compute node memory, and Slurm options, and so on, so that you can use those options very conveniently. And on the right side, we have, let's say, a mini example, so that you can just copy paste and then replace this hello, those things with your real program here, so that you can start your calculation right away. Yes, we have, let's say, covered the most commonly used options in Slurm. And next, I'm going to talk about more options, let's say, that is very useful if you have some special calculations. And the first,
Can I ask a question?
yes,
Previous page. If I remember correctly, in the Slurm, we have also had the option to define the memory size, also define the CPU core. But here, I think we need to use only node number. It will define for us how many default cores, how many default memory. Am I correct?
yes, you are right. So basically, here is a question from on-site participant. So one can also specify the number of the CPU cores in a job script, the memory that you would like to use for your job, and so on. Yes, exactly. There are options, and those options are not here, because otherwise this table will be invisible. So there are options. So this table gives you, let's say, the most commonly used options, and for most of the calculation, if you specify those options, and then the default settings will be used. And the default settings, for example, let's say one CPU core for one process, and so on. Those default settings make sense in most of the cases. So you needn't to worry about the technical details as long as your calculation runs without any problem. And if you have, let's say, any technical problems, you are welcome to write us email, PC2 support. I will repeat this again, PC2 support, and we are happy to help you to do those, let's say, fine tuning about your Slurm job script so that you can benefit the most from the cluster. Yeah.
By default, if I request one node, which means I have 128 CPU cores, 256 gigabyte RAM in default, right?
If without any other options,
Yes.
if you just specify -n, to request one node, normally you will just use the entire node, or the entire node will be, let's say, allocated without any other options, for example, number of the tasks and so on. Um, uh, so this is just some yeah, more fine-tuning options there. Yeah.
Excuse me.
Yes, please.
Where do you pass the file, basically the job name, the job file to the slurm command? It's the job name.
Yes, exactly.
So there we pass the file name.
No, the job name is just the
What if we have like other type of scripts we want to run? Maybe like a Java program, Python program. Is it also? It's also possible to like run it with the Slurm, right?
Yes,
Yeah.
exactly. So if you have a Python code, and then you will need to load the Python, let's say, software. We will come to this point later on in the last part of regarding to the HPC software. And then you just run Python, and then your Python code, and then everything works. Yeah. Yeah, you're welcome. I think we can move on, right, to the to this option. Yeah, even though I say this is slightly more advanced, but those options have use case. For example, the first one, the so-called exclusive option, as we talked about this before, you can specify exclusive to use the entire compute node for your calculation exclusively. And then all the CPU job or all the CPU cores in the whole node will be used. Yeah, and then even if your job only use one CPU core, this may be some, let's say, very extreme case, to allocate one entire compute node but use only one single CPU core. And this is possible, technically possible, and this is also useful for profiling your application, to get the accurate measurement for the timing of your calculation. And next is to redirect your output to a specific file. For example, to use the minus minus output option, and then to put all the output to this myjob underscore, and then %J, this is the job ID, and then you will have your specific file for this calculation. And also you can redirect the standard error file to a file so that later on you may want to look at if there's any errors in the calculation. And if you are sure that there's no error in your calculation and you don't want to be bothered by those error files, you can send all those error files to the /dv/null to the so-called black hole of Linux. And the next topic, very interesting topic, is how to use GPU on the cluster system. And I'm not sure if any of you want to use GPU or so. So you may think this is very difficult or yeah, because GPU sounds very strange. But actually to use it is very simple. You only need to provide 2 lines of options. The first line of option is to use the GPU partition, right? This makes sense because otherwise there's no GPU. And the second option is to provide those so-called grass option. Grass means the Slurm generic resources. You need to specify, okay, I would like to use GPU for my calculation, and which type of GPU would you like to use for your calculation? So for Noctua 2, you need to specify, for example, A100. For autos, you need to specify H100, because of different hardware. And then last but not least, you need to specify the number of the GPUs would you like to use. 1 GPU or 2 GPUs or even more and so on. So after that, very simple, just run sbatch GPU job, and then you have your GPU job running on the cluster. It's very simple, just 2 lines of Slurm options. And during, once you submitted your job, you may want to get notification to have, let's say, monitoring of your job. So this means you may want to receive email when your job begins, or when your job ends, or if there's any problem with your job, or some other information about, for example, time limit and so on. And then you can specify mail as information here to your Slurm options, and then you will receive, for example, email about the status of your job. For example, here, this is an email I used, and then I get the information. Now my job is completed, it's done, and then the next step is to, for example, analysis, to do some data analysis and so on. Yes, please.
In the two page, like previous 2 pages, yeah, 1 page previous also. When do we need to load the module?
You will need to load the modules normally after specify the Slurm options. Yeah, you can specify those modules. But yes, this is a good question. And this module or HPC software will be immediately the next session. Yeah, because in this session we focus on the upper part, and then we follow the logic, and then next session we will talk about modules. Yeah. So, monitoring the calculations. So to monitor the calculation for a running job, the simplest way is to log into the compute nodes and then to use htop or top or whatever to look at the status of the CPU. If all the CPU are running for your job, or if some CPU is lazy, doing nothing. This is one way to do the monitoring. And another way is, for example, if your job finishes, and then you may want to have this so-called efficiency information by using SF efficiency, and then followed by the job ID, or to look at the job information by use S act, so account minus S account or accounting minus J, and then followed by the job ID, and then you will see more detailed information. And to give you a feeling, here I'm showing you the so-called SF. So it will show you the job efficiency. For example, here I have one job, and then this job is completed. This job uses, let's say, 64 CPU cores, and it has CPU efficiency 97%. Yeah, 97% is not as good as 74%. Yeah, sorry, my head is broken. It has efficiency of 74%. This is not as good as 90%, but still reasonable, right? This is still a reasonable number. But if the CPU efficiency is like 10% or so, and then there may be some potential issues, and then you are welcome to send us this information so that we can look at together why this job is only using 10% of CPU and so on. And also for the memory, as you can see here, for the memory usage, we have 90% memory usage. This is also very good. So for those tuning and so on, it is very useful. And I think in 2 weeks or so, Alex will talk about how to optimize or how to tune your Slurm jobs. This is, let's say, an immediately follow-up topic for this course. So if you found it interesting, you can make registration, and Alex will talk about more about how to do this, let's say, more tuning and so on.
Do you have this for the GPU as well? Or is this only CPU and memory?
For GPU, I don't want to disclose the content of Alex's course, but we have information for that. Yeah, what I can say is we have the information for that. If you found it interesting, yes, I have to disclose the content of Alex's course. Alex will talk about, this job monitoring. You have very nice web interface. You can just click this figure to look at what's going on there, click that figure to look at what's going on there. So everything is very fantastic, much better than this, let's say, this text output. So if you found it interesting, you can make a registration, and I will show the link later. Yeah, this additional topic, those many visualization, you will have a very nice overview about your jobs. But I'm not going to talk about it right now. Yeah, it's too much. And last but not least, at PC2, we also have this PC2 user portal so that you can have a real overview about the system status, the dashboard, the queue, and Jupyter Hub. I heard one of you want to use Jupyter Hub. It's there, and yeah, many information available so that you will have a full overview of the cluster status. And last but not least, more information is available through Doku PC2 Uni Paderborn Day, so that you can learn more about running jobs. For example, priority, the job priority is a very interesting topic. We have more detailed documentation there rather than this very brief talk about job priorities. I think this is the end of the session C. So let's give it 20 minutes. And not really exact 20 minutes. Let's get back at 17:15, 5:15, in roughly 20 minutes. But before we close this part, do you have any questions that we can discuss? Yes?
Can I run multiple
Sure. So one very interesting, I think maybe a common question for most of the online participants is, can one run multiple Python jobs or Python calculations on one compute node? Yes, it is doable. You can submit multiple jobs like, I don't know, job A, job B, or even job C, and so on. And for example, job A use, I don't know, 8 CPU cores, job B use another 8 CPU cores, and so on. And then you can do this. And you already reach the so-called parallelization because you are running multiple parallel jobs. So this is also the topic for the next session, but you achieved parallelization earlier than the course. Yeah. Any other questions? Hello, everyone. I think we can continue to the next part. But before we dive into the talk, I would like to, let's say, briefly take a look the hands-on part. So basically, the most, let's say, important part, I will talk about this very briefly. So the first hands-on exercise is to submit a job to calculate, let's say, the first 5,000 digits of pi. You know, pi is a number with infinite digits, and then you can calculate the first 5,000 digits by using this simple command. The key message I would like to talk about here is not about how to calculate pi, of course, is to how to create this as a job script. So let's look at this together. I will give you a live demo. I think this is more interactive so that we can look at the calculation together. Can you see, I think you can see my terminal. Can the online participants also see my terminal? Is this clear for you? Large enough, the fonts? Okay, let's move on. So first you need to create this job script with some Slurm options. So basically you only need, let's say, minimal 2 options. The first option is to request 1 compute node. The second option is to request 10 minutes for this calculation. And then to find out what's the time is it right now, and then run this calculation, and then to find out what's the time is it again. You know, those 2 lines are optional, you know, just for mirroring the timing, and then to run the calculation. As you can see, this Slurm script is very simple, and then you just run as batch. Maybe you see here many warnings, but it doesn't matter, right? Because those are just the warnings. For example, memory usage or whatever, doesn't matter. You know, for some simple job, you just allocate 1 compute node, and then the job is running. I think the last one is the job. As you can see, 1 compute node is allocated for this job, and then the time is, yes, this is 1718. And if you use SQ, you see the job is running, right, in the running state, and on this compute node. So you can go to this compute node, and the job is done. And then I do not have any permission to connect to the node, right? Because the job is done, some other's job, you know, from your colleague or from other project may be scheduled. So this connection must be disconnected. Otherwise, you can look at the other's job, which is not good, or do not follow the privacy rule. As you can see, PC2, we follow the privacy rule very well. So the job is that. So I have to log in again. Yeah, sorry for this inconvenience, but this proves that we follow the regulations very strictly. But anyway, what I want to show you here is, as you can see, the command is only using one CPU core, right? The top part. Sorry, because this monitor is too small. But anyway, believe me, this job is only using one CPU core. I don't know, 99% or 100% or so. So this is not good. Let me disconnect. So this is not good because on one compute node, there are, for example, 192 CPU cores, yeah, on autos, but using one CPU core, this makes sense only if you are doing benchmarking, serious benchmarking. But for this calculation, this makes no sense. So that is why we really need parallelization. That is a topic in the next part. So I'm going to talk about parallelization soon in the next session.